wheelbarrows we saw. So this is about being, the thing that probably needs to be accentuated in the business models is to be ferociously proud and don't listen to people. And people that are profoundly successful have a belief in themselves. And so when the World Health Organization told me you couldn't do this, I didn't believe them. And that was because in mortgage, everybody told me lies as well about the world. And so I had to learn my own Rosetta Stone of knowledge and trust myself, trust my wisdom. And I think that's one thing that's often missing in people who are young entrepreneurs, is that lack of self-belief. So you have to have that to be successful. And then you can change the world. So right now, go next slide. That figure's gone up by 1 million and it goes up. So there's 11 million people now who've got one of my lenses. One thing I'm particularly bad at is I try not to leave a footprint in the developing world, because that's, you want to be culturally aware, so you don't try and change the nature of the culture of a country. And I've not been particularly successful about that at times, because I was explaining to the Prime Minister of Nepal about cataracts, what we've done in Nepal, and he could only speak, I thought, limited English. So I was miming to him and explaining it in great detail, and very laboriously so. And then the media people came along, were taking pictures. He leaned down to me and he said, actually, I have one of your lenses. And the other thing about technology transfer is that you have to train people in an applicable way. When we designed these lathes, which are very, very complex, I said, how are we going to service them? And so we had this very smart engineer. He said, what we'll do is we'll put a telephone jack plug into the computer on the lathe. That will then be downloaded in that lathe, and we can do diagnostic stuff from that lathe. And that worked for about 5 minutes, because the line was always choppy and they get one thing across a signal, and so it wasn't technically possible to do that because of the remote. So I said, okay, well what we're going to do is we're going to redesign the internal part of the lathe to what I technically call BRTs, which are big round things. So you get one big round thing, and you put voltage into it, and you get voltage out. And if that BRT fails, you replace it. So we modularised the whole thing with about 16 BRTs, which they could simply just measure the voltage in and out and get a replacement part. So just phone up somebody, didn't need. And when I was lecturing to people in Nepal about good manufacturing practice and maintenance of these things, I fortunately was very Kiwi-esque in my teaching program, so I would say to the young technicians, look, voltage going into BRT, voltage not coming out, BRT fucked to throw away. And anyway, so I'm in Nepal about 6 months ago, and there's a little Sherpa girl sitting on the floor. She's got the lathe in 1,000 pieces, and I said, do you know what you're doing? Because it looks like it's all taken apart. She said, yes, sir. And I said, when will it be fixed? He said, maybe tomorrow morning. And I said, the lathe will then be put together and all working. She said, yes, sir. I said, you know what's wrong with it? She said, BRT's fucked. So sometimes you need a cultural footprint and you don't really need to. Certainly the train will work. So we go to the next slide. So what happened then was that I realised that you could actually come up with technology platforms that made a profit and address problems that other organisations and governments weren't addressing on a global scale. So as a pharmacologist, I started looking around hospitals to see what were the next important things that needed to be fixed. And I was actually probably looking for an AIDS drug or an antimalarial drug or something like that. But what I found surprised me. We go to the next slide. One of the biggest problems was that in the treatment of patients, ultimately they end up with intravenous therapy. That's just having a catheter put in their arm and you'll be connected to a drip. And either a drug will be infused into you, or in the case of these patients here, you can see this particular family member is holding up bags for infusion for medical intervention in the world. So what we found though was that people were dying, next slide. They were dying simply because of this paradigm. On the left-hand side, you'll see if you go into an Auckland hospital, you'll get one of these high-tech microprocessor controlled mechanical pumps, which will accurately infuse the fluid into your blood, and the drugs also. But in the developing world, they're being asked to use this technology, which is at least 50 to 80 years old. And 3 millimeters movement is the difference between open and closed. So if you move it the wrong way, when you're doing an anaesthetic, you'll kill that person. But they never die of that over-administration. They always die of the underlying disease. Boy, global disease. And so it's a real important discovery. And how did this occur? Well, it occurs simply because of that inequity that we have in our world and the way that we think about starting a business. So the people that are in control of starting medical device companies say, who's our market? They're the rich people. So we develop this technology. We won't worry about these because no, they can't afford it. And in fact, in the developing country, they can't, not only can they not afford the pump, they can't afford to maintain and also electrical supply is often choppy in terms of voltage fluctuation. Or in the case of Paul, they only have 6 hours of power a day. So you can't, this technology will never be used in the developing world ubiquitously in my lifetime. So we need to come up with something that affects that problem, because this is the most common medical procedure in the world, and it's probably killing millions of people every year because doctors don't have access to the right control, particularly for things like chemotherapy drugs, which are very toxic drugs, and if you have more than a certain percentage, you'll die. Go to the next slide. So this, and particularly with babies, because babies have such small volumes, it's even more difficult to adjust the flow rate. So babies are at the leading edge of this problem. And each year there's about 2.5 billion drip sets used each year. So it's a huge monumental problem. So how do we go about fixing this problem? Go to the next slide. We invented this little thing, which is basically a device that you can clip onto any drip set on the outside of the tubing, and then you can dial up the flow rate. And it's got the same accuracy as $2,500 syringe pump. And it's completely unbreakable, and it costs about $5, so you don't have to ever replace it. So what this means is that the cost is actually nil. You amortise it over 25 years and the number of patients. So they can afford it, because sometimes a drip set on its own will approximately cost $5 US. So what we're doing now is talking with a major multinational medical device company who has the skills to sell this through both the developed world and the developing world, because it's also useful for Auckland Hospital, because they use these roller clamps for your normal saline drips. And when we did a survey of Auckland Hospital one-day snapshot, we found of 4,000 patients, only 5% were getting accurate infusion. The remainder of them range between 150% of their infusion rate prescribed and -50%. So it's a huge problem even for us in terms. So it's got a footprint in the first world for rest homes. You can also use it for dosing the chlorine in spa pools. It's really just a flow controller. So this is a neat solution to that problem that fits both in the first world and the developing world. And the beauty of it is that, you know, for a nurse, you go along the whole raft of patients. I was in China last week, and there were 1,000 people in chairs in their IV room, and none of them was probably getting anything like the right amount. And the nurses don't have time to check the flow rates. They just set it up, and within 10 minutes of being set, it's usually down to at least 50% of its prescribed flow rate. These things don't change. So she can run along and see the patients getting the right flow rate. So it makes the job a lot easier. And obviously, compared with 3 millimeters of movement, this has got a huge amount of movement, so the accuracy in precision is much greater. So it took a lot of